name is Dr. Esther Trufan, and in this video, I'm going to demonstrate how we move from knowing the mass of the tablet, knowing the mass of the cup with the water, or the cup with the water and vinegar solutions in it, to performing our experiment. So for this, the steps are very simple now that we spent so much time setting it up. We're going to take our Alka-Seltzer tablet from the little cup, and we're going to transfer it by a simple plop into the large cup that contains the water in experiment 1. It goes in, we give it a swirl, and this is the benefit of using a larger cup. It's not going to splash out. We place it on top of it and then slide it back, because very quickly we can move on to experiment 2, which goes the exact same way. The only difference is that in this case, we have a little bit of vinegar in our solution. Next, for experiment 3, there are 2 larger pieces here, so they get transferred together. And let's try not to lose any of our cups here, although we are done with the little red cups. Experiment 4. Experiment 5. Experiment 6. Experiment 7. And finally, experiment 8, which now only has the vinegar solution in the cup, and the Alka-Seltzer tablet is going in. We can see how our solutions are at different levels of effervescence. And what we see in all of them is the formation of bubbles. The bubbles are a sign of gas formation. And in this case, our gas is carbon dioxide. And as carbon dioxide is leaving the solution, either through swirling or just simply exceeding its solubility limit in water, we're going to see the bubbles come to the surface. If we swirl it a little bit, it helps drive off the carbon dioxide a little bit faster. So for the next about 15-20 minutes at least, what we're going to do is swirl all of these and check for bubbles, and then keep doing that until we observe no more bubbles in any of the cups. At that point, we will check back in with the experiment and collect the mass of all of them. It has been about 30 minutes since we combined our Alka-Seltzer tablets with our cups of water and vinegar solutions. I've been swirling it continuously, and now most of the bubbles are gone. We are ready to collect our final measurements. And so one at a time, we're going to bring in each of the cups and we're going to measure them again. And it is really important that we record all of our measurements every time. So I'm bringing back my green pen. First thing we're going to do is turn on our scale, tare it, and then place our cup on the scale and record our new mass. And in this case, it is going to be 51.00 grams. With that, I'm going to set this to the side. For my second experiment, and the red cups are empty, so I can combine them. I will start again with the scale at 0.00, place the cup on top, and record my new mass, which in this case is 50.62 grams. When I'm ready, I set it aside and slide it back. For experiment 3, I'm going to do the same thing. Place it on a scale and record the mass, which is 49.81 grams. For experiment 4, the combined mass after the experiment is 51.28 grams. For experiment 5, the combined mass is 50.04 grams. For experiment 6, the combined mass of the products inside the cup is 50.47 grams, and that includes the mass of the cup. For experiment 7, the mass of the cup with the products is 49.83 grams. And for experiment 8, the combined mass of the cup and the reaction products is 50.70 grams. Now, there are a couple things that we need to consider as we complete our data collection here. The first thing is, when we look inside the cup, we're going to see some white, fluffy solid that is not dissolved. If you read the contents of your Alka-Seltzer tablet, you should be able to identify what that ingredient is. And that has no impact on the experiment because it is a non-reactive ingredient. So it will be considered a spectator compound. The second piece is that your combined mass of the cup, your water and vinegar solution, and the tablet should ideally be more than your final measurement that includes the cup and the products. The difference between those two measurements is going to be the mass of the carbon dioxide that escaped through the reaction. So the difference between the mass of all your starting materials and the cup minus the mass of all your products and your cup will give you the mass of the carbon dioxide. From that, you can calculate moles, and you can calculate the number of moles and the grams of the baking soda that is part of your Alka-Seltzer tablet.